This is an R tutorial. Got 2 minutes? Learn some statistical programming in R. It's easy, free, and fun. This tutorial, how to generate a Bernoulli or binomial distribution without quaking in fear in R. This tutorial builds on the random number generation tutorial, how to generate random numbers according to different statistical distributions in R. So be sure to try that one on for size if things aren't clear in this video. We're going to avoid the heavier statistical concepts here, but I'll just say a Bernoulli distribution is an abstract way to think about an event that either happens or it doesn't. For example, a coin flip has two outcomes, heads or not heads, which would be tails, but it's easier to think about it as heads or not heads. Or, say, seeing a man dressed in a gorilla costume on your drive to work has two possible outcomes. Either you see the gorilla guy or you don't. For a coin flip, the probability is 50-50 that it's heads. You don't see a guy dressed in a gorilla costume on most days on your drive to work, so let's say the probability of seeing a guy dressed in a gorilla costume on your drive to work is 1 out of 1,000, okay? Great. All right, let's generate some random numbers with R. Use the R binom function. The R binom function has 3 parameters: the number of random numbers to generate, the number of trials that occur in each random number you generate, and the probability that an event will occur. What's all that mean? If you're trying to create a Bernoulli distribution, then the size parameter will always be 1, period. End of story. So here's what the function does. R randomly flips a coin 10 times, and it looks like 4 of those 10 times R came up with heads, and the other 6 times it came up with not heads, which is tails. Hey, let's make it quote-unquote flip a coin 100,000 times. And it looks like, well, about half of the coin flips are heads, and half of the coin flips are not heads. Neat. All right, let's test out the probability of seeing a guy in a gorilla costume on your drive to work. Remember, we decided that the probability was about 1 out of 1,000 that you would see the guy in the gorilla costume on your drive to work. If you drive to work 10 times, you never saw the guy in the gorilla costume. But let's say you drive to work 10,000 times. You might have a sighting, right? Let's save that result into X, and now X contains a couple of sightings. There's a sighting, there's a sighting, there's a sighting up there. If we take the sum of all the sightings, it looks like out of 10,000 times, you had a gorilla guy costume sighting 13 times. This has been a work of R.